Again, like I said, note that these homeworks are due for a grade. The homework permutations, the homework combinations, and the quiz that's happening on Friday comes from these problems. Okay, so it's imperative that you do them, right? And also understand them, because you'll see them. And guys, you know this by now. The only thing, if once after you understand the process of how to solve a math question, is the only thing that's happening is just changing the numbers. That's it. That's really all you're doing. Okay. So just make sure the quiz will open up Friday morning and it'll close Friday evening. Okay. So you got all day. Um, I will host a um, 1 p.m. help session on Friday, strictly just to answer any last minute questions that you might have. And that's about it. Okay. No new material. And then we'll pick up next week, Monday, Tuesday, Wednesday, Thursday, Friday. Okay. Same thing. Everything we do Monday through Thursday will be um, assessed on Friday. And these things that I'm asking you to do, these homework things, are not any different than what I have given you in the past as far as expectations and the format of our class. It's just we're not face to face, guys. Um, so, um, so there. What questions do you have? You got 20 problems on combinations. So let's hear it. You can put them in the chat. You can put it in the, um, you can turn your mic on and ask me. I will tell you this, the assessments that you're asked are the things that you're asked to do in the individual classes, even on mine, these homeworks, are what is determining whether you're present or not. If you're not doing them, then you're being marked. You're going to be probably marked absent. They're looking at that. They had to give a list this morning um, on that particular thing. So um, just know that, how do you take attendance? Well, attendance has to do with completion of work. So I think that's how they're going to look at it. But more information will come, and I'll provide it to you. Okay. All right, guys. Got a lot of people join. A lot of people here. It's 13 people, which is great. A lot of y'all I get to see every day, which is, or at least get to see your name pop up. But anyway, sure. We need to know that. Okay. Whoever, like, for example, y'all have got it, right? And when I polled sixth period, and everybody said they had internet connection, right? So first period, I'm pretty sure that y'all do. Um, I haven't found anybody yet, but they just need to email the teacher or call, or well, I shouldn't say call, but email, get somebody's phone and email them. Uh, y'all are notorious for being able to get or do what y'all want to do as far as achieve or complete. So I can tell you, sitting there not doing anything is going to be detrimental. Okay, so just get that information to them or get it to me. If you can get it to me, if you know people, then I can pass that information along. Not a problem there. Everybody should have my. Everybody's got my email, but I gave my cell phone um, in case you needed to get in touch with me quickly. Just text me, tell me who you are, um, and that way I can answer your question accordingly. But yeah, I'm probably not going to be too much of a help other than the 1 o'clock for you on Friday um, to answer questions. So just know that. Because Friday, if you're stuck on a problem on the test, how do I know you know, well, I do know you're on the test. I can see if it's in progress, and probably will be checking that. So just know that. Okay, let's look at content. Come on, guys. I got 20 problems. Either that's kind of the other day y'all blew me up on permutations, but maybe you're okay on combinations. Maybe the use of the formula and factorials uh, kind of got you. All right, Meadow said one. Do number one? Okay. All right, so let's go there. So if a person going to the party has to bring 3 different bags and they find 19 varieties, so n equals 19, r equals 3, right? So how many different selections can it make? So this is a combination, right? Because they didn't say a particular order of things, right? Order matters for permutations, not in combinations. So it's it's n factorial over n minus r factorial times r factorial, and that's all. So what we're doing actually is let me get this back, make sure that that's going. Yeah, is the dividing it by another number, which is just reducing the overall amount, right? So that would be 19 factorial over 19 minus 3, which is, I'm going to put in 19 minus 3 is 16 factorial times 3 factorial. So if you do this, that's 19 times 18 times 17 times 16 factorial all over. Make that go less there. And then I'm going to put the 16 factorial there times the 3 factorial, which I'll probably just do this, probably make a little bit more sense. 3 times 2 times 1, right? And you see that the 16s drop. So 19 times 18 times 17 is 5814 over 6. Also divided by 6, and so that's 969 selections, right? So yeah, it's pretty good. So let's go put it in and make sure that what we're doing is right. Always want to double check. Don't want to assume, right? So what did I say, 969? Yep, submit. Hey, okay, good. All right. So that was the first one. Any questions? And the rest of them work just like that as well, guys. Okay, but that was problem number one. While y'all are kind of debating on which other one you need to see or not, are you pretty clear with the schedule that I've given so far? Do you understand what's expected, what is due, when it's due, and how this week is laid out? Okay. That's the biggest thing. I want you to understand we'll probably do 2 homeworks, 2 contents a week, okay? 2 different things, and then we'll take a quiz on Friday. So very much like this week, we'll teach Monday, Tuesday be a practice day, Wednesday teach, Thursday be a practice day, quiz on Friday. So that's how it's going to go. Very much like what we have been doing. Nola wants number 10. So we can do that. Before I change, let me go here. All right, number 10. All right. So in a lottery game, player picks 7 numbers from 1 to 48, right? So how many numbers are they? 48, right? And R is what? 7. So, if you go 48 factorial, And 48 minus 7 is 41 factorial, right? That's the n minus r, right? So n factorial over n minus r factorial times r factorial. That's the equation. And then times 7 factorial. So again, guys, you just 48 times 47 times 46 times 45 times 43 times 42 times 41 factorial all over. I'm going to move the 41 factorial over here. 7 times 6 times 5 times 4 times 3 times 2 times 1, right? And of course, all we're going to do is just cross out. Notice that before we do all the calculations, notice that different choices the players have left in order. If order doesn't matter, they told you order doesn't matter, right? We should have told you, hey, it's a combination, right? How many different ways can we put this type thing? Or so permutations. Note that we on those type problems we had like first, second, and third place, or vice president, president, secretary, treasurer, all those type things. They specific slots, right? So just kind of know that. So all right, so 48 times 47 times 46 times 45 times 44 times 43 times 42. It's a big number, right? Divided by, let's see, 7 times 6. I put 7 times 6 times 5 times 4 times 3 times 2 times 1, all in parentheses, right? So that my denominator is encased. So what I mean by, I'll do all the top, right? And I'll hit enter and get some big number, some really big number, right? But then I'll hit divide, and then I'll put my parentheses, and I'll type all this in, okay? And when I do that, what that gives me is this: 736,2907,2. So that's what, 73,629,072, right? So questions? Y'all good with that? Okay, Meadow said she wants number 3. Anybody else? Hey Zeus, I have not forgot about your request you made yesterday. I am still looking at that. So just know that I'm still looking at that for you, okay? Number 3. Oh, do you want me to put? Let's type it in and make sure that I'm right. 736,290,72. 736,290. And here's videos of that, right? I haven't looked at the videos, but I assume that they show you the same thing that I did. We go over number 3. Over here. Yeah, okay. All right. How many handshakes are required for a group of 8 people to shake everybody's hand? Well, guys, the total people are 8. The R, I'm just curious, what do y'all think the R is on this one? Okay, got some 1s coming up. Got some 2s coming up. So, Sam, why are you saying 2? I want you to kind of explain your thinking on why you're saying it's 2, bub, if you don't mind. Oh, you're not going to turn your mic on and explain? You're right with your comment. 2 hands for each person, right? If you're not, so what determines what hand? Right. No, you're correct. You're absolutely correct. Good explanation. Guys, if you walk up to somebody, like if I walk up to you and I extend my left hand, then you're going to shake with your what? Your right hand. But if I extend my right hand, you're going to shake with your what? No, wait. Right to right, left to left. Let's think about this. Yeah, right to right, left to left. So sorry, it's kind of flipping that around. So it depends on who initiates the handshake, determines what hand you're going to shake with, right? So that's why. So, again, we're 8 factorial over 6 factorial times 2 factorial. Are y'all okay with me at this point, uh, by now, by um, the video that I have up online, the other stuff that I have up online, as far as, the formulas and the teaching of it. Y'all okay with me shortcutting it like this? Y'all okay with that? Y'all understand that this is n minus r, right? And that this is r factorial, right? If I put that underneath it. So good. Y'all are great. Okay. So I'm going to go 6 factorials cancel out, right? So I got 56 divided by 2, which is, I don't know, what is that? 28? I think that's 28, right? So I think 28 is the answer. And that was number 3. So let's put in 28. Let's see what happens. They had a written example right there with that getting help. There you go. Okay, so I need to get back to the chats. Yes. What? Okay, good. Y'all know when y'all are commenting that y'all understand everything. That in my mind, I'm picturing you sitting in your desk, right, at your specific where you're at, my location of the classroom. So just know that. That's just me. All right, I'm gonna do number 7. Um, I think Miss Chandler wanted that one, and we will do that. Shakira wanted that, so let's go to here. Um, boom. Um, Lucky Fur must supply 5 different bags of chips for a party. She finds 20 varieties, right? So she's got 20 items to choose from, but she's only choosing how many? Only 5, right? So 20 factorial over 15 factorial times 5 factorial. And again, I'm going to put the little, this is n minus r, right? And this right here is r. So you kind of understand how this is going. So 20 times 19 times 18 times 17 times 16 times 15 factorial all over. And I'm going to move to 15 factorial over here. And then I'll go 5 times 4 times 3 times 2 times 1, right? And then, of course, we cross those out. Have you saw the common theme on this when it goes to you're getting it to the highest factorial. You're expanding it all the way down to the highest factorial of the denominator, right? So just kind of keep that in mind. 20 times 19 times 18 times 17 times 16. That gives me a really big number. Okay. 5 times 4 is 20 times 3 is 60 times 2 is 120, right? I think that's right. So that should be 15,504 different selections, right? So we're good on that. Yay, nay. Okay. Yeah, I'm gonna put it in just to make sure that we're correct. So 15,540, right? So the rest of these on this right here, 20 questions, one of those is a video, okay, of the lesson. So I want to make sure that you are aware of that. It's just another, it's got a little box in there to click saying that you've watched it. It's just me providing you with another opportunity to see a lesson, to hear an explanation that may, if you have some gray area, may provide an opportunity for you to have a click to solidify something. They may say it a little bit different and go, ah, there it is, right? Okay. Anything else, guys? Yeah. Because this is n, let me go right here. This is n factorial over n minus r factorial times r factorial. It's a combination. On the previous, like when you did the permutations, we didn't have this right here, right? We just had the n minus r factorial over under the n factorial, right? So n minus r, 20 minus 5 is 15, right? And then the r is 5. With the combinations, the order doesn't matter. So if I have ABC, that's the same as CBA and everything. So you're taking out those redundant scenario where the order of the selection doesn't matter. Okay. If you were to do this same thing and didn't have the 5 factorial in there in the denominator, then your answer would be significantly higher. Actually, guys, it would be 1,860,480. It'd be your numerator, right? If you think about it, on this particular problem, that would be the permutations. So you can kind of see, like if we're at 1,860,000 right here, right? Let's see, do this. 1,860,000. I'm going to take that and boom, and I need to make that. Let's see, that so I can clean that up. If we look at this n factorial over n minus r factorial is really the top number. If you think about it, right? That's 20 times 19 times 18 times 17 times 16 with 15 factorials canceling out. So permutation wise, it would be 1,860,480 if there was a specific order. But with combinations, we don't care. ABC is the same as CBA, ACB, all that. But in permutations, all those different little scenarios are different. I mean, they're unique, right? So that's really what I want to make sure that I drive home. Okay. Let me go back over here. I don't want that. Sorry. Boom. 11 and 18. I don't know if that, okay, 11 and 18. So let me, no, Sam beat you out on that one. So let me go 11. And if that wasn't 11, oh, um, all right, I'm just going to work. I'll set this up. I'm not going to work this one totally out. We won't put it in just from sake of time. But N is 52. I have 52 to choose from, right? But I only need how many? 4, right? So how many 4 card hands can be dealt from 52 card deck, right? So 52 factorial over 52 minus 4 is 48 factorial times 4 factorial, right? So, if you look at that, 51, 50 times 49 times 48 factorial, and I'll put the 48 factorial here, times, I'll do 4 times 3 times 2 times 1, and of course, there you go, right? Do y'all need to see the answer on that? Okay. The basic thing is just setting it up. I do want to bring your attention to something. Y'all see this? What are these two things right here in purple or pink or lavender or whatever color you want to call them? They are videos of this particular type of problem, right? So I want you to think about that. All right. We'll go to 18 and let me go here. Let me get this and then go here. Um, I know some of y'all probably haven't watched all the videos yet as far as the lesson for today. I understand that, but you need to, okay? If I spent time out of my life to produce that for you, you need to go and see those insights because it's got a list of things in there, how to tell it from a counting principle, how to tell it from a permutation, how to tell from a combination. So, and that's smack dab in the later 2/3 of the video. So make sure that you do that, right? All right, a lock has 3 dials, right? On each dial are 7 digits. How many possible combinations are there? Oh, snap. Okay, this one is actually a multiplication one, okay? I mean by multiplication is we got 1 dial times 1 dial times 1 dial, right? So it's 3 dials. Um, so it would be um, 0, 1, 2, 3, 4, 5, 6, 7. So that would N would be 8 with R being 1, right? N would be 8 with R being 1. N would be 8 with R being 1. So I may take this one off if this is how I think it's coming out to be. What I mean by coming out to be, it's one that I shown on the video as far as showed multiple combinations. But so I'll do this. So 8 factorial over 7 factorial. Um, it could be, but it's probably a counting principle. I mean, if we're looking at it, um, all of these are going to come out. If you look at this, so 8 times 7 factorial over 7 factorial and times 1, that ain't nothing, right? So every one of them are coming out to be what? 8. So 8 times 8 times 8, what's 8 times 8 times 8? 512. So really that one is a counting principle, right? And they say different combinations. So, and we're going to go put that in. Boom. Yes. Okay, so that was 18. What's your thoughts? Nola, I have to check about number 20. Could you do this? I don't think that's really reaching out on this one if I have this particular one. The only thing that's going to change is what? Okay. So voting for this problem. This problem was Sam's. I think it was Sam's, right? Whose was it? No, maybe it wasn't Sam's. 18. I don't know who had 18. Who had it? Okay. Are y'all okay with this? If I keep a one like this, specifically like this and only like this as a multiple combination that you'd have to multiply? The rest of them will only have one scenario, right? Does that make sense? Um, so I'd like to keep this one just because it's a really, really good one. I like the lock. It's 3 dials. It's nothing more than, there's only one choice, right, out of 8 numbers. And how did I get 8? I counted 0, 1, 2, 3, 4, 5, 6, 7. And by the time I got to 7, I was on my 8th finger, right? So there. So it's really like a counting principle. So I like that one. So we'll keep it. And we got to check out number 20 because that one I think may be similar And if it is, that gives you 2 opportunities. Um, no, that's 20. That's not like that. Or is it? Huh. Well, no, it's just a regular combination. So here we'll work it and just make sure. Well, just took a picture of the whole screen, so give it a second. I don't know why it hit that, but it did. There. Yep. Let me cut. Go back in here. All right. So this one, 4-person teams with a swim team of 14. Okay. So the n equals 14, r equals 4, right? So 14 factorial over 11 factorial, right? 14, no, 10. 10 factorial times 4 factorial. Get that out of the way. So that is 14 times 13 times 12 times 11 times 10 factorial all over, and I'll put the 10 over here, times 4, 3, 2, and 1. So let's do this. Has everybody got calculators? I know your phone does, but access to a calculator at home? 4 times 2 is 12, times 2 is 24. Oh, how'd I get the 10? It's n minus r. This is n minus r, right? The 10's n minus r, and that's r, right? The combinations video, the formula for it is n over n minus r times r factorial. So, let's see, divided by, what did I say, 24, boom. So, 1,001 different teams, right? Uh-huh. Okay. Okay. Your nephew's on swim team before. Okay, let me type it in. Answer ought to be 1365. I don't agree. Your nephew. Ah, duh. Guys, what did we just mess up on? Here's our problem. Watch this. N's not what? N is what? Read it. Your nephew Dawson is on a swim team with 14 other boys. So how many total do we have? Gotcha. That's it. So here, let me rework it. I'll rework it. N is 15, R is 4, right? So 15 factorial over 11 factorial. We'll make sure that we at least get this correct. So 11 factorial, and that's 4 times 3 times 2 times 1. So let me do this again. Boom. That gives me 32,760 over 12. No, not 12, 24, right? 24. I got 1365. And if you look back at what they had, guess what the answer should have been? 1365. So do as I say, not as I do. Read the question, right? Read the question. It's always beneficial to do that. All right. Well, um, y'all good? Uh, Listen, guys, I tripped up on it too. So come on, beat yourself up. That's why I give you more than one chance, and two, you get multiple attempts, right? So there. Um, are y'all good? That's been a really good preview of what you see on combinations. Tomorrow will be a last opportunity to get your questions on permutations and combinations. We'll start with last minute questions on, excuse me, combinations, and then we'll switch over to permutations. Okay, so if you're going to join that tomorrow, you better um, you might want to jump on first thing at 1. 15 times 14 times 13 times 12 would be 32,760. So double check, make sure you didn't type something in wrong. Okay. Somebody asked a question. Can we go over 10? Yeah, I guess we can go over 10. But did we not go over 10 before? We not looked at 10? I feel like we have, but maybe we haven't. Yeah, we've looked at 10. Yeah, okay, so let me go back over. Da, 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 da. Right there. This is number 10. 1 through 48 is 48. If they said 0 through 48, that would be 49, right? But 1 through 48 is 48 people. No, this is number 10 right here, right, Esquivel? I mean, that's what I'm seeing, right? Yeah, 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 that's it. No, it was 11. Okay, do I need to go over number 11 or number 10? All right, well, Meadow, there's number 10. That's what you wanted, okay? So let's work another one, and then we need to. I got some other stuff I want to make sure y'all good on. 7. No, 7's already been done too. Um, yeah, 7's already been done too. It's a bag of chips. The bag of chips, right? This one. That's number 7. Okay. So let me do this.